My dear students, in the previous video, I introduced the topic multiplication of matrices. We see some examples also. Multiplication of matrices is possible. What is the condition for the multiplication of matrices? We have seen. And also, I derived multiplication of matrices is not commutative. With an example, we have seen in the previous video. Now in this video also, we have continued the topic multiplication of matrices only. Few more examples we have seen in this video. So consider the matrix A is 2, minus 1, 3 and B is a matrix minus 1, 2, 4. See, A is a row matrix. It consisting of 1 row and 3 columns. B is a column matrix. It consisting of 3 rows and 1 column. These two matrices A and B can be multiplied because the number of columns of the matrix A should be equal to the number of rows of the matrix B. Therefore, matrix of multiplication of the matrices A and B is possible, and the order of the product matrix AB is 1 by 1. The number of rows of A and the number of columns of B, that means 1 by 1. We will see the product AB equal to 2 minus 1, 3 and B is minus 1, 2, 4. The first row, first column only we have, that is 2 into minus 1 minus 2, minus 1 into 2, again minus 1 into 2, minus 2, 3 fourths are 12. We have to multiply a row element with the column element and the product should be added. 2 into minus 1 minus 2, minus 1 into 2 minus 2, plus 3 into 4 plus 12. So this is equal to minus 2 minus 2 minus 4. 12 minus 4 is 8. So the product of the matrices A and B is only single element 8. It is of order 1 by 1. Therefore A and B, by producting the matrices A and B row matrix with a column matrix, you will get a single element which is of order 1 by 1. This is an example. Similarly, in reverse multiplication, BA, the same for this row and column matrices. Now I am going to multiply BA, B and A. It is also possible. So, BA is equal to, what is B? Column matrix. Minus 1, 2, 4. A is 2, minus 1, 3. Here also, B is a matrix of order 3 by 1 and A is a matrix of order 1 by 3. Number of columns of B should be equal to the number of rows of A. 1 into 1, 1. So the product of BA is possible and also the order of BA is 3 by 3. That is BA, first row, first column, first row, first column, minus 1 into 2, minus 2. First row, second column, minus into minus, plus 1. First row, third column, minus 1 into 3, minus 3. You have to write in the first row, third column. Similarly, second row, first column, 2 into 4. Second row, second column, 2 into minus 1, minus 2. Second row, third column, 2 3s are 6. Third row, first column, 4 2s are 8. Third row, second column, 4 into minus 1, minus 4. And third row, third column, 4 3s are 12. See, this is a matrix BA, it's of order 3 by 3. This is BA. From this example also we can conclude that the product of the matrices AB is not equal to BA. AB is a matrix of order 1 by 1, which is a single element 8 we have seen, and BA is this, therefore this is also not equal, therefore matrix multiplication is not commutative in this case also. Okay? Now one more example I am going to give for understanding. A row matrix and a column matrix, and column matrix and a row matrix also we can multiply. Now consider another example. If A is a matrix 1, 0, 0, minus 1, B is a matrix 0, 1, 1, 0. It's a square matrix of order 2 by 2, and B is also a matrix of order 2 by 2. The number of columns of A should be equal to the number of rows of B. I already told you, if the two given matrices are square matrices, product AB and BA are possible, and we will see whether they are equal or not. We will see. First AB. 1, 0, 0, minus 1. And B is 0, 1, 1, 0. That is equal to first row, first column, 1 into 0, 0. First row, first column, 1 into 0, 0. 0 into 1 is also 0. 1 into 0, 0, 0 into is also 0 plus 0. First row, second column, 1 into 1, 1. First row, second column, 1 into 1, 1, 0 into 0, 0. Second row, first column, 0 into 0, 0. Minus 1 into 1, minus 1. Second row, second column, 0 into 1, 0. Minus 1 into 0 is also 0. So, this is equal to 0. You can write here 0. See, once again I will write. First row, first column, 1 into 0, 0. 0 into 1 is also 0. First row, second column, 1 into 1, 1. Plus 0 into 0, 0. Second row, first column, 0 into 0, 0. Minus 1 into 1, minus 1. Second row, second column, 0 into 1, 0. Minus 1 into 0 is also 0. Therefore, the answer is 0 plus 0, 0. 1 minus 1, 0. It is matrix A. AB is 0, 1, minus 1, 0. BA, similarly, we will see what is BA. B is 0, 1, 1, 0. A is 1, 0, 0, minus 1. Here also, first row, first column, 0 into 1, 0, plus 1 into 0, 0. 0 into 1, 0, plus 1 into 0, 0. First row, second column, 0 into 0, 0, plus 1 into minus 1, minus 1. Second row, first column, 1 into 1, 1, plus 0 into 0, 0. 1 into 1, 1, plus 0 into 0, 0. Second row, second column, 1 into 0, 0, plus 0 into minus 0. Therefore, this is 0, minus 1, 1, 0. See, AB is 0, 1, minus 1, 0. BA is 0, minus 1, 1, 0. Therefore, AB and BA are possible, but they are not equal. Here also, matrix multiplication is not counted. 0, AB is 0, 1, minus 1, 0. BA is 0, minus 1, 0. It is not equal. Therefore, here also matrix multiplication is not commutative. But there is a special case. As a remark I told you. Now, you consider the two 2 by 2 matrices, diagonal matrices, I mean. Two diagonal matrices of order 2. You consider, as a note I can write, A is a diagonal matrix 1, 0, 0, 2. B is also another diagonal matrix 3, 0, 0, 4. You know, diagonal matrix means principal diagonal elements are the elements of the principal diagonal or exist, other elements are 0. Principal diagonal elements are there, other elements are 0. It is called a diagonal matrix. We will see the product AB as in the case of previous case. Previous product 1, 0, 0, 2. B is 3, 0, 0, 4. Product, first row, first column, 1 into 3, 3, plus 0 into 0, 0. 1 into 3, 3, plus 0 into 0, 0. First row, second column, 1 into 0, 0, plus 0 into 4 is also 0. Second row, first column, 0 into 3, 0, plus 2 into 0, 0. Second row, second column, 0 into 0, 0, plus 2 into 4 is 8. Therefore, the product is 3, 0, 0, 8. It is 8. What is BA? The reversible multiplication B. 3, 0, 0, 4. A is 1, 0, 0, 2. The product, as usual, first row, first column, or 3 into 1, 3, plus 0 into 0, 0. First row, second column, 3 into 0, 0, plus 0 into 2, 0. Second row, first column, 0 into 1, 0, plus 4 into 0, 0. Second row, second column, 0 into 0, 0, plus 4 2s are 8. Here also what do you get? 3, 0, 0, 8. So in the case of diagonal matrices, commutative law is true. For the case of diagonal matrices, matrix multiplication or the commutativity is true in the case of diagonal matrices. So if A and B are diagonal matrices, then they exist, they satisfy the commutative law. Commutative law is true in the case of commutative law is true for the product of diagonal matrices for the product of diagonal matrices of same order. Same order. Here diagonal matrices of order 2 by 2. Suppose you consider the diagonal matrix of order 3 by 3. It's also true for the case of commutativity. In any case, diagonal matrix, exceptional case, this diagonal matrices satisfies the commutative law. That's all. Similarly, next one more example I am going to give now. Consider the matrices. Another example, consider the matrices A is 0, 3, 0, 4. B is a matrix 2, 0, 5, 0. You consider these two matrices, A and B, of like this. This is also 2 by 2 matrices. AB is 0, 3, 0, 4 into B is 2, 5, 0, 0. Here also you consider first row, first column 0 into 2, 0, 3 into 0, 0. First row, second column 0 into 5, 0, plus 3 into 0, 0. Second row, first column 0 into 2, 0, plus 4 into 0, 0. Second row, second column 0 into 0, 0, plus 4 into 0, 0. So what do you get? You get a 0 matrix of order 2. So if two non-zero matrices A and B are multiplied, it implies a 0 matrix. After multiplication we get a 0 matrix. This is it is different from the real number multiplication and the matrix multiplication. If the two real numbers A and B, the product of the two real, if A and B are two real numbers, A and B are two real numbers, then the product AB, then the product AB equal to 0, either A equal to 0, either A equal to 0 or B equal to 0. In the case of real numbers, if the product AB is 0, if A and B are two real numbers, then AB is 0, if either is 0 when either A equal to 0 or B equal to 0. Whereas in the case of matrices, if both A and B are non-zero, then the product AB is 0. Gives a 0 matrix. In the case of matrices, matrix multiplication, the product of two non-zero matrices gives you the 0 matrix. But in the case of real number, the product of two real numbers should be 0 only when either one of the real number is 0. Whereas in the case of if the product of two non-zero matrices, the product of two non-zero matrices gives the product of two non-zero matrices is a 0 matrix. It is one idea. If A is not equal to 0 matrix, B is also not equal to 0 matrix, but AB should be 0 matrix. A is not equal to 0, B is not equal to 0, but the product AB is 0. 0 means 0 matrix. This is true in the case of matrices. You remember this idea also. So these are the special implications on matrix multiplication. And we will see the exercise problems in the next video. Thank you.